Welcome to the session of camera and its control. This is the second session. While talking about their controls, we have talked that there are certain controls which is there in the camera lens itself, like you have focusing control, you have aperture control, and you have the zoom control. Apart from that, in the camera body, you have the control for exposure, that is the shutter. We have seen with the help of aperture, we can control the amount of light passing through the lens, and with the help of shutter, we can control the duration for which the light is allowed to pass through the lens and fall onto the focal plane. Now, in this session, we will be talking about the aperture as a controller of depth of field, depth of focus, shutter as a controller of motion, image stabilization, and at the end we will be talking about photographic image and its technical evaluation. The main function of the aperture is to control the amount of light that is passing through the lens. Apart from that, aperture also controls the depth of field. Now, what is depth of field? When we focus certain object before and certain object behind is also comes to an acceptable focus. Now, the total zone of acceptable focus area is known as the depth of field. The areas within the depth of field appear sharp, while the areas in front and behind the depth of field appears blurry. Depth of field is directly proportional with the f number, that is the aperture number. Now, what does it mean? It means that if you increase the aperture number, the depth of field increase. For example, if you are shooting at a 5.6, now if you move your aperture to f8 or 11, you will get greater depth of field than 5.6. Or if you are shooting at f5.6, now you decrease your aperture number, that is you are going for f4 or f2.8, then you will get less depth of field. Other factor that controls depth of field is the object distance, which is referred as u. Now, u is directly proportional with the depth of field. Now, if you are focusing an object at a distance, you get more depth of field than when you are focusing a object close to the camera. So, depth of field is directly proportional with the object distance, that is u. Then depth of field is also depends on the focal length of the lens. More the focal length of the lens, less the depth of field, that is depth of field is inversely proportional with the focal length of the lens. If the focal length of the lens increase, then the depth of field decrease. Depth of field is also depends on the circle of confusion. Now, to understand circle of confusion, first we have to understand the formation of image of an object. Actually, a lens looks at an object as it composed with number of points. For each points of the object, it sends the light through the lens and it forms an image on the screen as a point. For every point object, it produces an image point. Now, if the screen is moved little forward or backward, then what happens? Then the image does not produce as a point, but it produces as a circle, and the moment for a point object we get a circle, we find the image is out of focus. So, if the size of the point produced on the screen is bigger in size, then we find that it is in a circle and we find the image out of focus. Now, you can see the picture here. There is a picture shot with a 100 millimeter lens at f4, and then there is a picture here shot with 28 millimeter lens at f4. You can see the depth of field is more when we are working with the smaller focal length lens. When we are working with 28 millimeter lens, the depth of field is much more than when we are shooting with the 100 millimeter lens. Again, next set of pictures we can see that the same thing is shot with 100 millimeter lens, but here we have increased the aperture. Now, it has been shot with f22. Now, you compare this with 100 millimeter lens shot with f4 and the other one 100 millimeter lens shot with f22. Here, when we are shooting with higher f number, the depth of field is much more. Depth of focus is an optical concept that measures the tolerance of the placement of image plane in relation to the lens. In a camera, depth of focus indicates the tolerance of the film displacement within the camera, and it is therefore sometimes referred as lens to film tolerance. Now, what is this depth of focus business? Basically, we have to understand what is the depth of focus business. Actually, depth of field is in front of the lens and depth of focus is behind the lens inside the camera. Now, the distance from the lens to the focal plane, now that there is a tolerance, you can move the focal plane little forward or backward, it will not change or it will not affect the resolution or the sharpness of the image. Now, within this tolerance, you can place your film, and if this film moves forward or backward, to a certain extent the image quality does not differ. This is very important for motion picture cameras, where the motion picture film constantly moves at the focal plane. It moves forward, backward, there is a vibration, and all this been digested, and we do not get the blur image in the motion picture camera because of this depth of focus. In the last session, we have seen shutter as a controller of light, but shutter can control the motion, or it has an effect of on the subject movement. Apart from controlling exposure, the shutter speed has a dramatic impact on the moving objects. Very short shutter speed can be used to freeze the fast moving object. Look at this example. Whenever an object moves in front of the camera, the image inside the camera also moves. When the object moves fast or the shutter remains open for longer duration of time, then the image registers as a motion blur on the screen. Now, very long shutter speed are used intentionally to blur the subject for an artistic effect. Now, look at this example where the long shutter speed is being used to intentionally to blur the moving object. With the still camera, camera shake is particularly problematic when we are shooting at long shutter speed or we are shooting with the long focal length lenses. For example, for a focal length of 125 millimeter on a 35 millimeter format camera, vibration of the camera shake could affect the sharpness, and if the shutter speed is slower than 1 by 1/25th part of a second. Image stabilization is a technique to reduce the blurring associated with the camera shake during the exposure. It is used different optical instruments like binocular, astronomical telescopes and cameras, both still and video. Many digital SLR cameras have the sensor which is 2/3, 5/8 or half of the size of a frame of a 35 millimeter camera. That means the 35 millimeter camera frame is 1.5, 1.6 or 2 times of the size of the digital sensor. The latter values are referred as the crop factor. On a camera having 2x crop factor, a 50 millimeter lens provides the same field of view of a 100 millimeter lens. Therefore, can typically be handled for 1 by 100 part of a second. Image stabilization process permits use of 2 to 4 stop slower shutter speed permitting the same quality. Image stabilization is designed and is capable of reducing camera shake, but it cannot help reducing the motion blur caused by the subject movement. Image stabilizations are two types, one is lens based, another is body based. Both have their advantage and disadvantages. An optical image stabilizer stabilizes the image by varying the optical path reaching to the sensor. The key element of an optical stabilizing system is that they stabilize the image before it reaches to the sensitive material or the sensor. Now, this can be done in two ways. One is by controlling the lens, the other is controlling the sensor. Lens based image stabilization used a floating element that moved right angle to the optical axis of the lens using electromagnets. Vibration is detected by two gyroscopic sensors. One is detecting the horizontal axis movement, the other is detecting the vertical axis movement. As a result, this type of image stabilization only corrects the pitch and yaw of the axis rotation, but cannot correct the rotations around the optical axis. The image stabilization feature must be switched off when you are using the camera on a tripod, because it gives you an erratic results and it does not require. The main disadvantage of lens based image stabilization is the higher price tag which comes with every lens. Next is the sensor shaped image stabilization. In this, there is a sensor in the camera body itself which senses the movement and it moves the sensor, that is your CCD or CMOS. By doing this, you do not need a stabilization system with every lens. There is a gyroscopic mount used to stabilize the entire camera body. This is used when taking picture from a moving vehicle. This technique stabilizes the camera movement externally than internally. To do this, they attach a gyroscope to the camera body, usually utilizing the camera built-in mount. Another method for stabilizing video or motion picture camera is used with a Steadicam system, which isolates the camera from the operator's body using a harness and the camera boom with a counterweight. Apart from aesthetics, different technical parameters are assessed for technical evaluation. They are namely sharpness, noise or grain, tonal reproduction, contrast and color. Sharpness determines the amount of details of the image that convey. Sharpness is affected both by lens and the sensor. In the lens, it is the lens design and manufacturing quality affects the sharpness, and in the sensor the pixel counts and the anti-aliasing filters determines the sharpness. Sharp image looks aesthetically pleasant than the soft or blurred image. Because of this, most photographers try to sharpen their image in the post-processing application. But too much sharpening is used to result in harsh visible lines on edges and around the object. Over sharpening image looks too textured. Noise is a random variation of image density visible as grain in film and pixel level variation in digital images. Noise increases with the increase of film speed or increase of the sensitivity of the sensor with the help of electronic circuit. Typical noise reduction circuitry reduces the visibility of noise by smoothing the image, excluding the area near the contrast and the boundaries. This technique works well, but it can obscure fine low contrast details. Tone reproduction is the relation between the scene's luminance and the image brightness. It depends on exposure. An optimally exposed image, you get proper highlight details and the shadow details. But if the image is overexposed, the highlight details are lost, and if the image is underexposed, the shadow details are lost. The contrast is also known as gamma, is the slope of the tone reproduction curve. High contrast involves loss of dynamic range, loss of details or clipping in the highlights or shadows. Many viewers prefers enhanced color saturation, and accurate color isn't necessarily very pleasing. While we talked about controls, we talked about the lens control and the camera body control. In the lens control, we have talked about the focusing control, aperture control and the zoom control. And in the camera body control, we have talked about the shutter speed control. Now, both shutter and aperture have the dual function. They not only control the exposure, but they have other functions. Like the aperture, it also controls the depth of field, and the shutter, it also controls the movement of the moving object. Then we have talked about the image stabilizer, and then we talked about the different technical evaluation process to evaluate photograph.